Okay, well, welcome back to our weekly and maybe daily discussion. I hope we're having discussions daily because I think that's what you need in order to do well in this class, especially since it goes at such a fast pace. But maybe looking at these lectures and listening to them and trying to read my chicken scratch, you're feeling more and more comfortable with these types of calculations in a laboratory environment. And in this section, you're working on concentrations, right? That's what this whole module folder is about. So you're going to be seeing concentrations in form of molarity, concentrations in form of normality, parts per million, parts per billion. And it seems kind of weird in the beginning because this video section, maybe a couple of videos here, is going to concern percent composition. And a lot of people scratch their head and they're probably going to say, well, that's not concentration, but it can be. Percent composition can be concentrations of things, and percent composition can be used in concentrations of things. So I thought that it was fitting to lump percent composition in this module folder and not the previous one that was basically all about fundamental calculations as far as chemistry and a laboratory is concerned. So in this video, we're going to talk about percent composition, the very basics, and you probably have seen these types of calculations in Chemistry 151 and 152, but we're going to review them. So with this video, if you are comfortable with percent composition, my advice to you is to go ahead and maybe fast forward this video to the very end. Just make sure that you don't skip anything in the middle. Make sure that I'm not going to introduce anything new that you did not know. And I think that you probably will be ready for the assignment. But in the next video, the majority of the assignment at least, in the next video, we're going to turn percent composition on its head. And we're going to look at it in a different way. And those types of calculations you probably will want to pay attention to. And then after that, attempt the assignment completely. I think that you'll be perfectly fine after the second video here. So if you're okay with percent composition, I'm okay with you fast forwarding me and flipping to the very end of this video. It's not going to hurt my feelings because I probably wouldn't know it anyway, right? Okay, so let's talk about percent composition. What really type of calculation are we doing? So the percent composition is basically taking a compound, and so we're going to use sodium chloride here, NaCl, and we're going to break it down into its individual components. So we have sodium and we have chloride. And we're going to go to the periodic table and we're going to pull the atomic mass from the periodic table for each one of these. So sodium's 22.99 and chlorine is 35.45. Well, if there were subscripts there, we would multiply by subscripts. You know the drill, right? We did this in formula weight. And then we're going to add these two things up. So I'm going to pull up the calculator just so you can kind of follow along and know where these numbers are coming from. So 22.99 plus 35.45 equals 58.44. So 58.44 is the formula weight for the compound. Well, this is half the battle of percent composition, right? That's all that this was. If you can do a formula weight calculation, then you're halfway there to percent composition. No big deal. So percent composition should be fairly easy if you feel comfortable with formula weights in the previous module and from a previous chemistry or laboratory course. But there's one extra step that we do for percent composition, because what this question's really after is what percentage of the weight is from sodium and what percentage of the weight is from chlorine, right? Meaning that out of this 58.44 grams per mole, how much is contributed by sodium and how much of the weight is contributed by chlorine? And that's where the percent calculation comes into play. So in order to calculate these percentages, what you would do is that you would take the amount that sodium contributes to the system, 22.99, and you divide it by the total, the formula weight of that compound that you just calculated. And then you multiply by 100 because, you know, this is percentage. And in order to calculate percentage, percentage basically means part per hundred. That's what this line means, part per hundred. So we multiply by 100 to get a percentage, right? And we do the same thing with chlorine. We take chlorine's weight, which is 35.45, and we're going to divide it by the formula weight, which is 58.44, and we times by 100. So if you can get formula weight, this next step is pretty easy, right? You just take piece of the whole. That's all that we've done. What piece of sodium is related to the whole, and what piece of chlorine is related to the whole formula weight. All right, so I'm going to bring up the calculator, and we're going to calculate the percentage, 22.99, and we're going to divide it by 58.44, and that gives me 0.39339493497760, blah, blah, blah. And we're going to multiply by 100, and this gives us a percentage. So 39.34%. I'm going to round it off to 2 decimal places. 39.34%. That's basically the percent composition for sodium, right? Meaning that out of the formula weight, the 58.44, sodium is worth 39.34% of that total. That's what percent composition is basically telling me. 39.34% of that weight is coming from the sodium ion. Well, I do the same thing with chlorine, right? I'm going to bring up the calculator, and I'm going to take 35.45, and I'm going to divide by 58.44, and then I multiply by 100, so I can change it into a percentage, and I'm going to get 60.66. So 60.66%. So it looks like the majority of the weight of this compound is coming from chlorine, right? That's what percent composition is telling me. 60% is coming from chlorine, and close to 40% is coming from sodium. So if I take a look at these two ions, sodium and chlorine, chlorine is the heavyweight. Chlorine is bringing with it the most mass, so therefore that percentage is higher for that reason. Now, something that I want to say over here to the side. Once you get these percent compositions for each of the atoms that make up the compound, add them all up, right? Just double check yourself. 39.34 plus 60.66 equals 100. If you get close to 100, like 99.9 or 100.1, then this probably means that you did the percent composition correct, because these are the only two things that make the compound up. These are the only two things that contribute to the formula weight. Therefore, when you add all the pieces up, you should get 100% of the weight of the compound. So hopefully that makes sense. It's a quick way to double check yourself to make sure percent composition is calculated in the correct way. All right, now, what if we got subscripts? Well, it doesn't matter, okay? So I'm going to do CaCl2. That's a subscript. This is an example. You treat all subscripts the same way, just like you do formula weight, right? So I need calcium and I need chlorine. So for calcium, that's 40.08 from the table. And from chlorine, it's 35.45 from the table. Well, there's one calcium, so I multiply by 1, right? We didn't do that up above because they both were 1, so no big deal. And then chlorine, there's a 2 there, so I need to multiply by a 2. Okay, so I'll bring the calculator up so you can see where the numbers are coming from. So 35.45, and I'm going to multiply by a 2, and that gives me 70.90. All right, so 70.90 is the total weight from chlorine. So I do a formula weight calculation just like above, right? 70.90, and then I've got 40.08. I've calculated the formula weight of the compound, so that's 110.98. Pretty good. You're already halfway there. So the question could be calculate the percent composition of this compound. And what that means, they want you to break apart, figure out what the percentage of calcium is, figure out what the percentage of chlorine is, right, in this particular example. Or they could be very specific, and they could say calculate the percent composition of calcium or calculate the percent composition of chlorine. They don't want you to do it all. They just want you to focus on just one, and that's it. And if so, that's good news because it limits my work, right? Okay, so in order to calculate the percent composition here for each one of these, I do what I did up above, right? I take the part, calcium, 40.08, and then I divide it by the total weight, 110.98. And then I do the same thing with chlorine down here, but I don't use 35.45, right? There's more than one chlorine. I use the total weight contributed by chlorine, and in this case, it's 70.90. So 70.90 divided by 110.98. Now, I got to convert them to percentage, so that means I've got to multiply each one of these by a 100. All right, so I'll take 40.08, and then I'll divide that by 110.98. Then I hit enter, and then I multiply by 100, and that gives me 36.11. So 36.11% of the weight is coming from calcium. Okay, so let's do the other one. I'll do 70.90 divided by 110.98, and then I multiply by a 100, and that gives me 63.89. So 63.89% of the weight is coming from chlorine. Well, I told you double check it, right? Don't take yourself for granted. You can make mistakes. So this is a quick check. So 36 and 11, and then 63.89. I add the two together, and I get a 100 as an answer. So not necessarily a concrete, yes, you did it correctly, but it's a pretty good indication that I did the process at least the proper way. So 100% is represented. Okay, so if we step back and take a look, the majority of the weight of the compound is coming from chlorine. That's close to 70 or a little over 70%. Or sorry, that's a little over 60%. And then a little bit of the weight's coming from calcium, and that's not quite 40. It's 36% that's coming from calcium. So the reason that I'm telling you this, and the reason that I'm repeating it, is because that kind of concept will be very important in the next video. So this is just one type of percent calculation question that you're going to get, okay? All right, so let's do one more example. And in this example, I'm going to do copper 2 sulfate pentahydrate. And we want the percent composition of each thing. So we can do the percent composition of copper, of sulfur, of oxygen, and of hydrogen. Well, that O's already listed, right? So I don't have to write that one down again. So what is the percent composition of copper 2 sulfate pentahydrate? Well, that's where I would start. So if you go to the periodic table, you're going to find copper. Copper is number 29, and the weight for copper is 63.55. So 63.55, multiply by 1, because there's just one of those, and I get the same number. All right, well, sulfur is number 16 on the periodic chart. That's 32.07. And there's just one of those, so 32.07. All right, now it comes to the oxygen. Oxygen's number 8 on the periodic table, and oxygen weighs 15.99 something. So we always rounded it off to 16, right? So oxygen 16, and we need to multiply it, right? So there's 4 that's coming from here, and look, keep this in mind. This 5 in front goes to the hydrogen, and the 5 also goes to the oxygen. So there's 4 oxygen from here. Well, water has 1, but that has to be multiplied by a 5. So another 5 is coming from the water molecule. So 5 plus 4 is a total of 9. Okay. So if I bring up the calculator for those that need it, 16 times 9 is equal to 144. Now hydrogen. Well, I get to the hydrogen. There's 2 for every water molecule, and then there's 5 of those. So 5 times 2 is 10. So 1.01 times 10 is equal to 10.10. So I do the formula weight for the molecule. I do 63.55 plus 32.07 plus 114 plus 10.10. And that gives me 219.72. So that's the formula weight. So I've got to calculate the percentage of each one of these. So I'm going to take 63.55 divided by the total of 219.72, and then I multiply by a 100 to get a percentage, and that gives me 28.92. Well, I do for sulfur, 32.07 divided by 219.72, multiply by 100, and that gives me 14.60. Next, 16 times 9. That gave me 144, not 114, right? 144. That's why I double check that one. So that 144 is going to be divided by 219.72, multiply by a 100, and I'm going to get 65.54. And finally, 10.10 divided by 219.72. It should be little bitty because that 10.10 ain't contributing a lot. And it looks like it's going to come out to be a 4.60% rounded off. All right, so I'm just going to add all my percentages up just to kind of check. So 28.92 plus 14.6 plus 65.54 plus 4.6 equals 113.66%. So at this point, I know something's off, right? Something doesn't quite make sense here. Well, I'll tell you what it is. When we did this formula weight, we did 63.55 plus 32.07 plus 114 plus 10.10. And that gave me 219.72. But when we did these percent calculations, we picked up on this error that we made, and we used 114 and not 144. So I'm going to go back and I'm going to have to redo my formula weight here. 63.55 plus 32.07 plus 144 plus 10.10. And this gives me 249.72. So now I need to go back and recalculate all of my percentages. I need to take 63.55 and I need to divide it by 249.72, not by 219.72. So I'm going to quickly make these quickly make these corrections here. So just give me 1 second. And with the magic power of the TV, now they're all corrected. So over here to the right-hand side, you're going to see the corrected percentages, but keep in mind that we would have never picked up on that if we didn't add our percentages together, which is why I always tell you to do that at the very end, right? If you get a number close to 100, then you can kind of think, I pretty much did it the right way. And we saw that there was a mistake, so we knew where to fix it, and we went back and we recalculated. So 25.45% copper, 12.84% sulfur, 57.66% oxygen, and 4.04% hydrogen. The way that I got these percentages, I took the totals that I got from here, and then I divided it by the new formula weight that I made the mistake on a couple of minutes ago. So 249.72. And then you multiply by 100 to get a percentage. When you add all of these up, you're going to get a 99.99%, and that's close enough, right? That's going to round up to 100. All of these are rounding errors that are happening, so I know I'm going to be a little bit off or a little bit above or below when I add these things up. As long as I'm close, that's all that matters. All right? So that's another example of doing percent composition using a hydrate in this case. Now, one more example I want to do before I turn you loose to go to the next video is what if we did the same thing, right? Cu2SO4 5H2O. But instead of saying what's the percent composition of the following compound, meaning that they want percent copper, percent sulfur, percent oxygen, percent hydrogen, what if it said calculate the percent composition of water in the above compound? All right? How would we do that? Okay, so here is another way to look at percent composition. You would do it the same way, copper, sulfur, and oxygen. And then down here, you can write water together, okay? So copper is going to be the same as above, 63.55, and there's just one of them, so 63.55. Sulfur's 32.07, there's just one of those, so 32.07. The oxygen that's included in just the copper sulfate, right? Because this question wants you to focus on water. So just the oxygen in the copper sulfate, there's 16 of those, or 16, there's 4 of those. So 16 times 4, if my pen works. And then we make it to water. Now, water, that's what the question's after. What's the percent composition of water? All right, well, if we look at water, we do a formula weight for water that's 16 plus 2.02. That's 18.02 as far as the formula weight goes. So I'm going to kind of treat that as its own entity, its own piece, right? 18.02. And there's 5 of these waters, which means that we're going to multiply that by a 5. This is kind of the quickest way to do it. So 18.02, and we're going to multiply by a 5, and we get 90.10. Well, I do just like I did up above. I now add all of these together. It's the same compound, so it should be the same formula weight, right? 63.55 plus 32.07. Okay, let me try this again. 63.55 plus 32.07 plus 64 plus 90.10. And that gives me 249.72, right? That's what we got for the formula weight right up here at above. So I just wanted to go through that process one more time to show you that nothing's changing, right? We're not doing anything extra. We're not doing anything different other than the fact that we kept water together down here at the bottom instead of breaking it up. And the reason I did that is because it wants the percent composition of water. It could care less about copper, sulfur, and oxygen. It doesn't want me to calculate percentages of those, like the question up above did. It just wants me to focus on water. So the total weight from the water is 90.10. And the total formula weight from the compound is 249.72. So I'm going to take those two numbers, I'm going to divide them, and I'm going to multiply by a 100. So 90.10 divided by 249.72. Then I multiply by a 100, and I get 36.08%. So 36.08% of the weight is coming from the water that's associated with the hydrate. So that's how you would do those types of questions, right? Sometimes people think it's easier to separate each individual one out like we did up above, and we can get percent compositions of each one. Other people, this kind of makes sense to them, right? Some people have to think about it a little bit, and they eventually get there. But just keep in mind, the percent composition of water means they want you to keep that water together. They don't want you to separate it out. So look at your water molecule, take the formula weight for water, 18.02, treat that like a mass from the periodic table. Then multiply by the number that you have. So in this example, there was a big fat 5 out in front, so we took 18.02 and we multiplied by 5, and that gave us 90.10. So that piece divided by the total weight gives me 36.08% hydrate. So 36% of that weight is coming from water. If that water was driven off, if that water wasn't there, then the whole percent composition begins to change. Okay? So that's it for the first video. Just basics of percent composition and how do we calculate those percentage. Now, in the second video that you're going to watch, we're going to take the concept of percent composition, we're going to change it up a little bit. We're going to kind of apply what the percent composition would be used for in a real laboratory, in a real life scenario. So stay tuned. If you're going to watch a video, watch the next one. This could have been a review. Maybe it was a good review, but the next one, maybe some parts of it you haven't seen. So come back for the sequel.